This lesson is for FST, lesson 5-6 on inverse tangent. Remember that inverse can also be considered or called arc tangent, and when you write it in symbol form, you just write tan with what looks like a -1 exponent, even though it simply indicates that it is an inverse. Remember that when you're doing inverse equations, you switch x and y on a graph. When you try to do an inverse, you simply reflect the original graph over the line y equals x. We did this plane problem when we did lesson 5-4 on inverse sine. So we're going to try it again, this time using inverse tan. I'm going to draw the picture a little differently this time. I've got my airplane flying. I know for some kids, they like to draw the triangle this way. So I want to talk about the angle of depression now. When you do the angle of depression, it's always from a horizontal down. And so in this case, that would not be included in our triangle. So because of the laws of alternate interior angles, the angle you're trying to find is actually down here. So just be careful here, it's not this angle up here that we're finding this angle here. So let's label our parts. The altitude is 6 miles up, that's the height from the ground to the plane, and the distance away from the airport, which is down here, is 100. So now if we're doing the angle here, the angle of depression, which is the same as this angle here, we would do the tangent function if those were the values that were given. So we'd say tan theta, and we would do opposite over adjacent, so we do 6 over 100. When you do the inverse tan of both sides to get theta alone, you'll simply type in inverse tan of that fraction, and you should get an angle of about 3.4. You'll find that if you revisit lesson 5-4, that was the same answer that we got. The only difference was when we did the inverse sine, we were using the 6 and the hypotenuse instead. But again, when you're doing an angle of descent, particularly on an airplane, you want to make sure that that angle is fairly low. So if you get an angle that's much bigger than that, you might want to revisit your problem. You probably did something wrong there if you're getting a much bigger angle than 3. Let's look a little bit deeper at the inverse tan function itself. The original tan graph is in blue here. And remember that it's got those asymptotes wherever the cosine is equal to 0. So there's asymptotes here and here. So at -90 and 90, you'll have asymptotes. If you flip that blue graph over the green dotted line here, over the line y equals x, you'll get the red lines here. Notice that if you drew a vertical line through this graph, the red graphs would not pass the vertical line test. So what we do is we restrict the original graph to be just this value here in the middle. So just between -90 and 90 with the asymptotes included. So if we restrict the tangent function to just be this graph only, now if we flip it over the line y equals x, we get this graph here. So notice that the domain is all reals, but the range is now from -90 to 90. And so when we work with inverse tan, we actually have the same restriction as when we did inverse sine. So you're working with -90 to 90 degrees as your only values that are possible. Or if you think about it on the unit circle, we're only talking about quadrant 1 or its opposites. So keep that in mind when you're working with problems involving inverse tan. So here we are with some inverse tan problems. Let's do a quick review. Remember, if you're working with the tan of 30 degrees, that ends up being square root of 3 over 3. Tan of 45 degrees is 1, and the tan of 60 degrees is square root of 3. We had already calculated those back in a previous chapter. I had instructed students to simply memorize those values, and we'll need them here when we do these problems. If we're doing arctan of 4 in degrees, this would have to be a calculator question. You would not be able to figure that one out using your unit circle. So that one you literally have to type it in, and when you type it in degree mode on your calculator, you should get about 76 degrees. So go ahead and try that on your calculator. The other way to do the second problem here of the inverse tan of -square root of 3 is to check out the tangent graph from lesson 4-6. You could also go back here and know that whenever you get a square root of 3 for tan, we're dealing with a value of 60 degrees, and then we'll have to convert that to radians. Because it's a negative value, you know that on the unit circle, we're only going to be dealing with quadrant 1 or its opposites. So we know that square root of 3 is going to be a 60-degree measure. But because it's a negative, we want to say -60. And in radians, that value is pi over 3. And I converted that real quickly. I also have that one memorized. If you didn't know that, you would have to go ahead and convert it yourself. And then the last value here, inverse tan of -1. Again, a 1 is going to come from an angle of 45 degrees. Because it's negative, we'll just say simply -45 degrees. And in radians, we would say -pi/4. So it is important to have these values for tangent memorized because there's no way for you to derive those values from a baby calc only. So these last two questions will be baby calc questions. And if you don't know square root of 3/3 and square root of 3 for tan, those problems will be quite difficult.